beautiful people, and welcome. In today's video, we are talking about solving systems by substitution. So I did record two other videos prior to this one. So we have already gone over graphing and we have gone over elimination. So this is the third type of way to solve systems. This is the last way to solve systems that we're going to learn. As always, disclaimer time, I am a human. If I make a mistake, please let me know where the mistake is so that way I may learn from it and that way you don't have to make the same mistake. All right, let's go ahead and get started. So solving system of equations, what is that again? It is two equations, or it are two equations? No, it is two equations that we are solving for the x and the y value. Now, there are three types of answers. They are the same as we did for elimination. So we can have one solution, no solution, or infinitely many solutions. Let's go ahead and write that down. So we could have one solution. We can have no solution. And we can have an infinite number of solutions. So if you have one solution, your answer is going to look like x comma y. So you need to first solve for x or y. It doesn't matter which one it is. So let's not call it first. You're going to solve for x. You're going to solve for y. It doesn't matter which order you have. Now, for your no solution, this gives you an always false statement. And what that means when you have an always false statement is something that's always not true. For example, 5 is equal to 0. 5 is never equal to 0, so this is false. This will always be false, so that way you will have a no solution. An infinite number of solutions, kind of the opposite of no solution. We will have an always true statement. And for example, an always true statement is something like -3 is -3, x is x, 0 is 0. Always true. -3 will always be -3, x will always be x, 0 will always be 0. Now, for your answers, if you get a false statement like this, then your answer is no solution. You actually write no solution. If you get an always true statement, your answer is infinitely many solutions, or an infinite number of solutions. However, if you get one solution, if you're able to solve for x and you are able to solve for y, your answer is going to look like this. It's going to look like a point. It is the point of intersection for both of these lines. So you're always able to check your answer by going to Desmos or a graphing calculator. Desmos is fantastic online. You can type in both of your equations and double check if your answer is correct. All right, let's go ahead and jump into an example. I'm going to try to give you some steps for each example and go from there. Example 1. And for each example, I want to elevate the complexity of it. For each example, it's going to get a little bit harder and harder, more difficult. All right, so let's do this one here. Y is equal to -5x minus 21. Y is equal to 5. So again, what's our objective? Our objective is to substitute or replace. Let's do a thinking bubble. Substitute a value for a variable. So for example, we have 5 is equal to y, and we have y is equal to -5x minus 21. So what we are going to do, we're going to substitute this 5 into my y. Now, if I have multiple y's, I can do that for all y's. So I'm going to pick this y up, and I'm going to put it in place of this. So let's go ahead, and I'm going to rewrite this. I'm going to say I have y is equal to negative 5x minus 21. But we don't want y because y is 5. This tells us y is 5. So because y is 5, this y will now be 5. And now that you have substituted a value in for a variable, so your variable was y, your value was 5, the next thing you're going to do is you're going to solve for the remaining variable. After you solve for the remaining variable, you're going to use the answer. You're going to use that solved variable to solve for your other variable. Now, I'm not being specific which variable because not always will you substitute for y. Sometimes you're going to substitute for x. All right, so this is now what I have. Let's go ahead and solve this. Here's our dotted line. I have 5, negative 5x minus 21. I'm going to add 21 to both sides. My 21s cancel or they go away. They undo each other. So here's 26 divided by 5. Excuse me. Bring down the negative 5. Now we're going to divide by negative 5. This is multiplication. I'm going to divide by negative 5, divide by negative 5. Now this gives us a fraction. That's okay. Fractions are still your friend. We're going to keep it as a fraction. So these go away. X is equal to 26 fifths. Let me scooch this up just a little bit. And that is your x. Does it matter that it's not a pretty number? That's okay. Whatever it equals, that's what it equals. We're not here to judge, right? So this is a fraction. Keep it as a fraction. Don't change it to a decimal because you're going to see magic things happen. So now you're going to use the solved variable to solve for the other variable. Okay, this one right here, and you're going to plug it into the other equation. You can plug it into any equation you want. But I'm going to show you something pretty cool for this specific equation. So if this is given, notice that they already gave us 5 is y, so or y is 5. So because of this section right here that they already gave us, not always will they give you something like this. This is just our beginning example. Because we know what y is, and that's given to us, we're done. We don't have to solve for the other variable in this example. Now, typically you would have to. So is this your answer? No. Is this your answer? No. So your answer is a combination of both. You're going to put parentheses, you're going to put comma. So your x is negative 26 fifths, and your y is equal to 5. And that is your answer. So we got super duper lucky on this example because we didn't actually have to solve for the other variable. But let's go ahead and do another example where we actually have to do that. So let's jump into example number 2. For example 2, we have y is equal to 3x minus 15. And we have negative x minus 2y is equal to negative 12. So that's our system. So our objective remains the same. So I'm not going to keep copying. I'm only going to add steps if we need to. So our objective is to substitute a value for a variable, solve for the remaining variable, and then use the solved variable to find the other one. Let's do that. Let's first substitute a value into a variable. Notice that I have y is. This equals is translated as is. So y is. So that means that this is my value that I need to substitute in for my variable y because they give me y is. So how would this look like? Well, I'm going to rewrite the bottom equation, but I'm going to rewrite it a little bit larger than you're going to be used to. So I have negative x minus 2. Now, instead of y, I'm going to put, well, let's actually put y here for our first. Let's rewrite this, but now instead of y, I'm going to put parentheses. So this is your y. Y is this part right here. Well, what is y? Well, here is y is 3x minus 15. So I am going to take that 3x minus 15 and I'm going to bring it to y because that is what y equals to. And then I'm going to put it inside of my parentheses. Now, it's super important to put it inside parentheses because you're going to have to distribute most of the time, the majority of the time. So you're going to have 3x minus 15 in place of y. We substituted that value. Okay, so now we continue solving. So now we are solving for the remaining variable. So here is our remaining variable, which is x. So I'm going to solve. So I have negative x. Oh, did you guys see this? We're going to have to distribute like I mentioned. Make sure you're taking a symbol with it. For example, this 2 is negative. So I'm going to say negative 2 times 3x and times a negative 15. Make sure that you take that negative 15 as well. So I have a negative 2 times 3, that's a negative 6x. And I have a negative 2 times a negative 15. I don't know what that is, but I know that 15 plus 15 is 30. So I'm going to say it's a positive 30, and that's still equal to your negative 12 on this side. I'm going to go ahead and do a dotted line at this point because we are now combining like terms and simplifying to solve for our variable. So I have a negative x and I have a negative 6x. That means I have a total of a negative 7x. I still have my plus 30. That did not change. I'm going to bring that down. And I still have my negative 12 on my right-hand side that I did not touch. Now this should look like a two-step equation for you, which it is. I'm going to subtract 30 on both sides. Lots of negatives. If you're uncomfortable with negatives and you are allowed to use calculators, I urge you to use calculators. So that way you're solving, but you're not making those little hiccups. So I have negative 42 on my right-hand side. I still have my negative 7x on my left-hand side. These are attached by multiplication. How do I undo multiplication? By division. I'm going to divide both sides by negative 7. Doing a happy dance because two negatives make a positive. So I have 42 divided by 7. And I believe if you're not sure, use a calculator or use your hands. 6 times 7, 1, 2, 3. 6 times 7 is 42. So I have a positive 6 for x. Is that my answer? This is not the answer. We're actually going to use this to solve for y. Now, how do I solve for y from here? Pretty similar to how we did with elimination. Once you solve for one variable, you take that variable and solve for the other one. So you're going to choose one of your given equations. So you're going to choose one of your given equations. You're going to substitute for x equals 6. Remember, x is 6. So we know that because we solved it. So which equation am I going to choose? Let me look at them. Honestly, it doesn't matter. I like this one, the one on top, because this says y is. I don't have to, I have an x and a y on the same side on my secondary equation. And I feel like, to me, that's a little bit more complicated. But you can choose whichever one you want. I'm going to choose the one on top. Let me copy it down, and then I will shift my paper. Okay, let me shift that up. So we have this one here. This is the one that I chose because it already has y is, and we now are solving for y because we already have an x. So I'm going to take my x value, I'm going to plug it in, and I'm going to replace x with my number. So I have y equals 3. Always use parentheses when you are substituting anything. So x is 6. I'm going to plug that in. This says 3 times 6, which is 18, minus 15. 18 minus 15, 15, 16, 17, 18. That is 3. I like to count up. So y is 3. Is that my answer? No, that is not my answer. So what is the answer? We have all of these numbers, all of these variables that we solve for. What is the answer? You're going to take both of them. And your answer is a combination. It's parenthesis, comma, your x value, and your y value. All right, let's do one more example. Let's kick it up a notch. Make this a little bit more challenging. Here we have 8x minus y is equal to negative 23. And we have 4x plus y is equal to negative 1. Now, this is where it's super duper duper important to read the directions, especially if you're taking a test. This we want to solve by substitution. Resist the urge to start eliminate. If now on a test it doesn't tell you what method to use whichever method you want. You can graph it if you want. But for our purpose, we want to only use substitution because that's what the directions say. That's what this video is about. Okay, so when you're solving something like this by substitution, notice I do not have a y is. I do not have an x is. So when you're doing that, you're going to pick an equation, pick one equation. You're going to pick one of the given equations. It doesn't matter. I'm going to say easy one. And then you're going to solve for y. In this case, we can solve for y, or you can solve for x. From these examples, the computer generated more of the examples that we are solving for y, but that's okay. If you have one that's easier to solve for x, it doesn't matter. Just solve for x instead. I'm going to choose which one do I want to solve for. I'm going to choose this one. So I'm going to say 4x plus y is equal to negative 1. My objective right now is to solve for y or for x. I think it's going to be easier to solve for y because I already have a plus 1y here. I'm going to subtract 4x both sides. Here's my dotted line. Oops, sorry about that. So my 4x's goes away. What do I have? I have a y. I have an equals, and I have a negative 4x minus 1. Okay. Once you are done solving for y, you're going to do exactly what we did in examples 1 and 2. Here's our original points. You're going to substitute a value in for a variable. Here's our two equations that were given. We have manipulated, that's a bad word. We have altered the second equation to have y is. Remember, equals means is. Because we have y is, now we can substitute a value in. So here's our value, our 4x minus 1. We can substitute this value into our y for our top equation. So let's bring this top equation down. And I have 8x minus y is equal to negative 23. Now this is super duper important. Make sure that you are taking your y, doesn't matter if it's next to a number or not, you have to put it in parentheses because things will happen. If you don't, you're going to end up making a mistake. We don't like mistakes. They happen, we learn from them, but we don't like to make them. All right, so we have 8x minus, bring everything down except your y. Instead of your y, you're putting parentheses. We still have our equals and we still have our negative 23. Now, instead of your y, you are going to substitute or replace your value, which is now what we solved for, a negative 4x minus 1. This is why it's super duper duper important to put your y in the parentheses, put your variable in the parentheses when you're substituting. Notice that I have this minus here. This minus means I'm multiplying by this minus. I need to distribute that minus. It's weird, I know, but pretend you have a -1 here. And you're basically saying I have 8x -1 times 4x minus 1 is equal to -23. This -1 needs to be distributed because we are multiplying the entire bubble. I know there's a lot of arrows, I apologize. We're taking this -1 and we're multiplying into the bubble. So what do I have? Let's move down from our arrows. 8x, now multiplying. -1 times a -x, which gives me a positive 4x. -1 times a -1 gives me a positive 1, and that's still equal to -23. Now I'm doing my dotted line because we can now combine like terms and simplify. 8, 9, 10, 11, 12 x's. I still have my plus 1. Here's my -22. I'm going to subtract 1. I have 12x is equal to -20. What is this? 3? All right, divide by 12, divide by 12. Oh, do you guys see that mistake that I did? I'm like, something's not right. This should be 23, and when I rewrote it, I changed it to a 22. That's incorrect. So let's change it back to a 23. That should be a 23, which would give me a 24 here, because -23 minus 1 is a -24, which is better, much better, because I know that this is going to be a -2 when I divide. Now, is this my answer? Everyone shout with me, no, that's not our answer. We have to now use this variable to substitute into one of our equations to solve for the other one. Now, I want you to notice that we have now 3 equations. So we have the first one that we used here. We have the second one that we used here. And we have the third one that we actually solved for. It is your choice if you want to use the one that you worked with or if you want to use one of these. It doesn't matter. This one, if you did it correctly, should work just fine. However, if you don't want to, that's okay. We can do that one instead. So let's choose the bottom one instead if you're not comfortable or you're not confident in your work. So I have 4x plus y is equal to -1. And what are we doing? We are taking our x value, our x is, and we are going to replace the x that we have by using parentheses. So we have 4 parentheses plus y is equal to -1. What does x equal to? X is -2, so we're plugging in -2 here. This is multiplication, so I have a -8 plus y is equal to -1. Dotted line, this is a one-step equation. I'm adding 8 to both sides. Use a calculator or counters or a number line for this one here, which would give me a +7. Now, is this my answer? Everyone's screaming out, no. The answer is combined to have -2 and 7 for your y. All right, beautiful people, this wraps up this video. I apologize for the mistake for the number here, but that's okay. We caught the mistake, we fixed it, and we are going to learn from our mistake. As always, thank you so much for watching my videos, and I will see you in the next one.